Now that we have a nice high-res simulation cached out, let's go ahead and start meshing our sim. So it's nice to have a particle fluid surface here that's being used to display just the particles. So I'll rename this existing particle fluid surface to View Particles. As you can see, this output is just set to display those particles with that velocity visualization. If you'd like, you can also flip the Visualize setting to Vorticity. So this shows you all the areas of high vorticity, and that will come into play more when we do our whitewater simulation, although you can potentially use this in the shading process as well to perhaps add a bit of diffuse color or something in the areas where that vorticity is quite high. For now, I'll just flip the visualize back to velocity. And in addition to giving us this nice display of the particles, the particle fluid surface also allows us to do the meshing to build the actual polygon surface from our particle sim. So let's create another particle fluid surface. And for this one, I'm going to leave this output convert to setting to surface polygon soup so that we build the actual mesh that we're going to render. And we'll get some very nice results, even just leaving all of these parameters at their default value, except for this particle separation. It's important for this particle separation to be set properly to match what we've actually used for our sim. So once again, we're going to go back to our flip source and copy our particle separation parameter from there. Just copy that and then go down to the meshing and paste that into the separation parameter on the particle fluid surface. Paste in that relative reference, and let's connect that to our cached out sim. And after displaying that particle fluid surface, it did take a moment to compute all of this meshing. Took a little bit more than 40 seconds on my machine right now, and this is all looking quite good. If you zoom in on this, it does look a bit low res. That's not really a problem because for any close-up shots, we're going to resimulate a portion of this and up-res it, which we'll take a look at soon. But for our wider shots, this is all looking quite good. However, we can refine this a bit, and we do need to chop off these sections at the start and end of the river here. So if we zoom in on our mesh a little bit and take a look at the filtering tab, we have some options here to dilate and erode the surface and to do some extra smoothing on it. And you can see here that the erode option is linked to another parameter. And the parameter that's linked to is the checkbox for the dilation. So if we turn on the dilate, then it's also turning on the erode, and this is refining our surface a little bit more. If you were to just do the dilation without doing the erosion, then it would just expand the surface, which probably wouldn't look very nice. But when you dilate and erode by the same amount, you're essentially smoothing things out in a nice way. You could do a similar thing if you were to do a VDB from particles, and then do a couple VDB reshapes on that. You could do a VDB dilate, and then after that do a VDB erode, and then convert those VDBs to polygons, and that would do something similar to what this particle fluid surface is doing here. And that smoothing can really improve the look of our final mesh. In addition to that dilation and erosion, you can also turn on some additional smoothing with this option here. And that difference is quite subtle, but it does add a bit of extra smoothing on the mesh. So for this wide shot, I was pretty happy with what I was getting out of the default dilation and smoothing and erosion. It does refine the mesh a little bit overall. So I'll just stick with those default settings there. And now we can take a look at chopping off these sections at the start and end of our sim. Because currently, these guiding area extensions are included in our final mesh, which we definitely don't want. So if we go to the Regions tab on the particle fluid surface, you have this option here to subtract collision volumes. So let's turn on the subtract collision volumes here, and this isn't going to do anything yet because we haven't actually provided anything to subtract. And if you mouse over the second input on the particle fluid surface, you can see that's the input for these collision objects and volumes. So this is where we'll provide those areas that we want to remove from the final meshed sim. And to define the areas that we want to remove from the sim, I'm going to go over to where we set up the boundary sync, because for this section, we imported our base of our terrain and scaled that down to sim scale and transformed that a bit and poly extruded it, and we can reuse that stuff to help define the area that we want to remove from the meshed output. So I'll go ahead and copy the object merge for the base along with the other transforms and poly extrusion. Just copy that and paste it in over by our particle fluid surface here. And for now, I'm going to display the cached river sim and control template display our extruded base. And I suppose we could try to dial in the exact area that we want subtracted from the mesh with our current display, but it might be a little bit easier if we set our display to our area of interest. So zooming in on this end portion of our mesh here, select this transform SOP. This is the one that's transforming based on the centroid. It's lifting up the base in Y and transforming that out a bit with the uniform scale. So instead of transforming this out, let's transform that in a bit. So if we just set the uniform scale to 1, then that perfectly lines up with the edge of our terrain here. So currently, we're seeing this end section included with our output mesh. But now if we connect the subtraction region that we just defined to the second input of the particle fluid surface, we'll see that area cut out of the final mesh. So this is looking quite good, and we can check the back end of our river as well to make sure that that end looks nice also. This looks all good as well. And now this meshing is a little bit slow to process. It's taking around 40 seconds to a minute to generate this mesh from our cached out sim. So we certainly don't want to wait for this to process every single frame when we're displaying this or flipbooking it or rendering this out. So let's go ahead and cache out this mesh to disk. So we'll drop in a file cache. I'll call this cache river mesh. Connect that to the particle fluid surface. And I'll point this cache to the river directory and wide river vo1. And I'll make a new folder here for the mesh and set the file name to river_mesh.$f3.bgo.sc. And similar to our simulation cache, I'll Control-Shift-Click to remove the expression from here. And I'll set the end frame to 300 to match our simulation cache range. Set this to load from disk, and then hit Save to Disk to cache out the mesh. Now the cache for the river mesh is finally finished, and this did take a very long time to cache out, but now that it's done, let's take a look at how this looks in motion for the full shot. So just for a bit of a nicer display on this, I'm going to do something similar to the velocity visualization that's on the particle fluid surface here. Let's drop in a wrangle, connect that to our river cache, and call this speed from velocity. And I have a wrangle preset to generate the speed from that velocity just by getting the length of that vector. And now let's drop in a color SOP. Set the color type to ramp from attribute. Let's display that. In the attribute dropdown, we can select speed. And then I'm going to grab the same colors from the particle fluid surface here. So if I go to the velocity ramp there, I'll right click that parameter, copy that, go back to our color SOP, and paste in the values here. And right now we're getting mostly values of 1 because our speed goes significantly higher than 1. We can check the spreadsheet on that if you want to see what the range looks like. So I'll sort by the speed column. And it looks like it goes from about 0 up through almost 10. So I'll set the range accordingly, 0 to 10. So now we have a nicer display for our river here. And now let's see this in context with the rest of the environment. So I'll get rid of the template view and then set our viewport to show all objects. And now our river mesh is at simulation scale, but everything else is at proper rendering scale. So let's scale the river back up. So we can just copy any of our sim scale transforms from our flip setup. So I'll grab one of these here, and I'll paste this just after the file cache. I'll call that sim scale invert. Control-Shift-Click the invert option to get rid of that expression link, and then flip the invert on. And then I'll go back to our render camera. And I suppose we could change the color ramp on this to make it look a bit nicer. I'll rename that color to color from speed and adjust the range so that we don't see so much white in here, just to make it a bit nicer for our flipbook. And because this is just for the flipbook, we don't have to make this coloring perfect. I like how it looks when the range is set from -5 to 50. And I'll pin my display to this river setup here and go back up to the object level, and let's display our high-res environment. So diving inside the environment here and going to the very end of that setup, let's display the full ENV. And before we do a flipbook to see what this looks like, I'm also going to add a time shift to this. Because if we go back to the very first frame, you can see our river is totally flat. So if we go back to the river setup, then we can add our time shift just before or after our sim scale here. It kind of doesn't matter where you put this stuff. I'm going to just pull this visualization stuff off to the side, since that's just for flipbook purposes, whereas these transforms and time offsets are actually going to be used for rendering. So let's add in that time shift, place this just after our file cache, and I have a preset already set up for this time shift, so I'll select that time offset here, and I'll try an offset of 40 frames. So that seems pretty good from this still frame here, and then we can do a flipbook of the entire shot length to see how it looks overall. And now after flipbooking the entire shot range, this river mesh is looking really nice. So we can go ahead and start rendering this. And there really isn't very much that we need to set up render-wise for this, because we already set up a render object for the water and we set up a shader for that already. So all we need to do is drop in a null here, connect that to our sim scale invert. You don't need to include the speed from velocity and the color from that speed in our render setup. That's really just for a visualization. So I'll just attach that null to our sim scale inversion, call the null render water. And of course we can make a netbox around our meshing setup just to keep our scene nice and clean. I'll call that river meshing. And I'm going to unpin our viewport display from our river setup here, then go up to the object level and dive inside our existing render object for the water. And this currently has the temporary surface that we set up earlier. So we can just take this object merge and we can point this to the river setup instead. So I'll change this path to object/river/render water. And you can see that's bringing in our mesh here. And if you turn on velocity trail display in the viewport, you can see our meshed river has velocity on there, which we'll be using for motion blur in the render. And we can check those motion blur settings on the actual render object here. Under Redshift Object, Settings, and Render, if you scroll down to the bottom, you can see this is set up to use the point attribute V for velocity, but you do have to turn on Mesh Deformations Blur from Velocity attribute. And for the shader on this, we've already set that up earlier in the course when we did the rendering with our temporary water. So we can just leave this water shader as is. And then going over to the out context, let's take a look at our wide ENV render here. This is already set up to render the environment and the rocks and the water, with the creatures as a phantom object. And for your final renders, I would recommend adding in the explosion and fire and shockwave and dust as phantom objects as well, so that you can get the nice influences on the lighting from those additional elements, but we don't need to add that right now so that we can keep our current render a bit faster. So let's open up our Redshift render view, and under Houdini, select ROP, let's pick wide ENV, and run a render to see what this looks like. And for this IPR render, I'm going to turn on the render region, and set that region just on the water area, just so we can focus on sampling the area we're most interested in right now. And I'm also going to turn on bucket rendering because that seems to go a bit faster. And you can see two different buckets rendering at the same time because a recent graphics driver update allowed me to get both the graphics card in my eGPU working along with the internal GPU in my laptop. So we get some render power boost that way with both of those cards running on this render. And this still frame here is looking quite good. It's always a good idea to render out the entire frame range with a little bit lower quality just to see how nice everything is looking when it's all in motion. And ultimately, once everything's rendered out and composited together, you'll wind up with a result that looks a bit like this. And this river simulation and this render here has a whitewater element applied as well, which we obviously haven't done yet, and we'll be taking a look at whitewater simulation next week.